So what tangent line is doing? It's doing a lot of very interesting things with curves. Okay? So one of the interesting things that curve is doing with the tangent line is doing with the curve is that really if you look at really the neighborhood of this point, you can approximate the curve by the tangent line actually. In other words, that if you see it locally means that you just go deep down actually and you zoom it up, you'll see that the curve and the tangent line are indistinguishable actually. They are distinguishable certainly if you look at the curve and the tangent on a bigger interval, but locally they are not, you can certainly see, you can't differentiate both. So where is curve and where is line? Okay, so the tangent line gives you a good approximation to what you call the curve at the moment. You can't spot the difference between tangent line and really the neighborhood of that point. So in other words, if you want to know about the curve, that how it is curving, just trace out, just look at, just keep an eye on the tangent line actually. Okay? What is the slope of the tangent line at this point?
Negative.
So it's really negative actually. Okay? I mean, so that's the first thing that we should see, that why derivatives are an interesting way to know that how a curve is curving. That if you want to know at a point that how a curve is curving and how much a curve is curving, okay, just take that point and draw the tangent line and look at the slope of that tangent line actually. So that slope is going to tell you that whether the curve want to increase or decrease or want to stay silent, want to do what. Okay? And if you see this tangent line on the different points, you're going to see that. So what does this mean? I mean, as I am going more and up, this tangent line is gaining, losing it's becoming more and more negative actually. So somehow the values are, in other words, the curve is taking more and more negative values actually. That's what essentially it tells you. And if you are trying to go down, what else you can obviously see is that this curve is gaining the slope actually. Okay? And if the curve is gaining the slope, in other words, that the slope is increasing, that means that the curve should also increase actually. In other words, its values should be, should get more bigger and more bigger and more bigger as gradually you go along it. Is it making sense? Okay. So that's the first thing that we should appreciate about the tangents and the curve. That really the tangent lines tells you the mood of the curve actually, that how curve want to curve, whether it's in mood of increasing, that's in mood, decrement, or you want to stay silent, what? Is it making sense? So what is the next thing? The next thing is that I would like to really talk about the extreme points of this, this curve. So see what interesting thing happens with the, this extreme point. You will see that, okay, these are the inputs and the curve is really representing the outputs. You are tracing out the outputs actually. Okay, so what are you going to call this point actually? So this point is really the point where the curve have its least value. It has a minimum value actually. Okay? Minimum value. There are two things actually, one is the minimum, okay, sometimes we say that x equal to 3 is minimum. Then x equal to 3 is not really minimum. What actually you are saying is that x equal to 3 is the input which will give you the minimum output of the function actually. That's what it is really. When you say that you have a some point, some input which is kind of giving you a maximum, it doesn't mean that that point is maximum, that value of x is maximum, but that really says that if you take that point and substitute it into your function, it's going to give you a maximum value. Okay? That's another important thing. Now, if we all agree that this spot represents really its minimum value, now let's look at what happens with this line, okay, when it goes around the maximum value. So what is happening with the line when you are trying to reach this point more and more closer? What is happening with it? Okay. So the first, the tangent line has negative slopes, then it becomes 0, and then it gains the slope actually. Okay. Then it gains the slope. Now the trouble is that, if I'm looking at a picture, it's not difficult to find its maximum and minimum actually. But if you are, for example, solving an abstract circuit actually, and you want to know that, okay, at what time you're going to have a maximum current. Okay? Or you have an abstract function, some complicated function, and you don't see you're not looking at the graph of it actually. Then how you can spot, without looking at it, that whether you have where you're going to have the maximums and minimums of that function actually. So the real thing is this. So when you're looking at it, certainly you know that, what are the maximums and minimums of it. But when you have an abstract function, the real trouble comes then that you want to find the maximum and minimum for such kind of a function. But this gives us a good hint actually. This gives us a good hint. So why this gives us a good hint? So whatever is the minimum, before the minimum, the tangent line is, must have a negative slope actually. It must be decreasing. Negative slope का मतलब यही है ना? Okay, so if the tangent line has a negative slope, this means that the function must be decreasing. Okay? So the function is decreasing and then increasing. And then you must have a point where you attain what you call 0. Are you getting the point? So if the tangent line has a negative slope, and we know that we can compute that slope by computing the derivative of the function at that point. So if you compute the derivative of the function at this point, at this point you're going to get the slope of the negative line, slope of this line actually. Are you getting the point? So what is happening before this point is that the function is decreasing, in other words the slopes are negative, and after that the slope becomes positive actually. Okay? So you're gonna say that, okay, so this gives you kind of a hint actually. So if a point, an input is what do you call a minimum value, so it should have two basic properties. Number one, at that point the curve should stop changing actually. In other words, should stop changing. Right? So stop changing. So it doesn't have any slope. Okay? Secondly, you need to keep an eye before and after that input actually. So what is the crucial input here that we are talking about? So x equal to 0. So what is happening before x equal to 0? A little bit x equal to 0, you see that the curve is decreasing. And what do you mean by the curve is decreasing? That when you draw a tangent line, it has a negative slope actually. And after that point, after this 0, the tangent line, gains a positive slope actually, and hence this simply represents that the function is increasing. So can we agree on a definition that an input is a minimum if before that input, if you take the inputs before that inputs, you're gonna get the function is decreasing on those points, and after those what do you call that potential minimum input, the function starts increasing actually. In other words, a point would be maximum, minimum, First of all, if the tangent line has zero slope, in other words, that the function has stopped increasing and decreasing. Okay, are you getting the point? And before that point, before that critical input, okay, so before that point, which you call the critical point or the stationary point, or lots of names for it. Okay, the function is decreasing, and after that, the function is increasing. In other words, before that, the slope of the tangent line is negative, and after that, the slope of tangent line is positive. Actually, okay. So we can say what we can say. Let's just keep track of this. So I'm going to say that a point, an input for a function is minimum. Okay. If what happens? If the function stops changing at that point actually. In other words, if at that point you draw a tangent line that will be parallel to x-axis and hence has a slope 0. Okay, and what is the slope of the tangent line is simply that you compute the derivative of it and equate it to 0. And that equated to 0 should be 0. Okay. And if you take, for example, really a small neighborhood of this A, you take, in other words, A minus delta and A plus delta. Okay? Some values before A and some values after A. Okay? Then what should happen at A minus delta? The function must be decreasing, in other words, that the slope of the tangent line must be negative, and f of A plus delta, in other words, the slope of tangent line, which is really the derivative, must be what you call increasing actually. Are you getting the point? And at that point it must be 0. So it's a very natural, what you call, kind of way of doing things. And you're going to have a precisely same kind of a situation when instead of a concave up curve, we have a concave down curve actually. Think about it. Okay? So where the heck is tangent line? Okay, fine. It's really at the top. Alright? So what is happening before the curve, before this critical point?
So slope is increasing.
You are saying that the slope is increasing, but the slope is positive actually. And hence function is increasing. That's what it means actually, that when the slope of the tangent line, which is really the derivative f prime of x, if it is positive,
function is increasing.
It's increasing, and if it is negative, function is increasing. By the way, you can also say this in this manner, and it's a better way to say that f prime of x must be less than or equal to 0 when you choose the x from, say, A minus delta to A, and it must be, what do you call, greater than or equal to 0 if you choose x from A to A plus delta actually. In other words, if you look at the outputs of these, what do you call, inputs, the function is increasing. And if you look at the outputs of these inputs, the function is decreasing. So this must be the minimum point. Okay, and you're going to say that A is the minimum. It's a value. It's the input which is going to give you the minimum value of the function. So where would be that point on the graph actually? So this would be the point on the graph. So A, f of A. So that's the point on the graph which is really the minimum actually. Okay? So A is the point where the minimum occurs, and f of A is the minimum value. Okay? That's really the minimum value, and this is going to be the point on the graph. Okay? Yes. And now if you trace out, for example, so now apparently this looks that okay, that the curve is having a peak at, this point. Is it making sense? So what is happening before this point? The line has a positive slope. In other words, the derivative of the function, okay, since I'm not writing a lot of this stuff because this is one dimension actually, this is stuff. Okay, so before that the derivative of the function is positive, okay, and after that the derivative of the function becomes negative. In other words, the tangent line has a positive slope before this critical point, critical input, and the negative slope after the critical input actually. And that really makes sense actually. Okay? So in other words, you want to reach to the peak, so what you need to do? So you need to, first increase the things, and increase the effort to reach at that point, and then you have to decrease the effort to get to the other side actually, correct the point. So it really makes sense. So I can write a similar kind of a thing. So you're just gonna have other way around. Okay, you just have other way around. And this is really what you call the first derivative test. Okay? So this is really what you call your first derivative test. That's what is your first derivative test. You find the critical points, you check what happens before the critical points, and you check what happens after the critical point, and then you decide that whether you have a maximum or minimum. Okay? Simple. And then you have this other funny test actually. Okay? We call the second derivative test, which is favorite of all. Okay? Because there you don't have to do all this analysis. Check the points before, and after. So you just compute the second derivative and see what happens. What is the sign of it actually? Okay? What is the sign of it? So why this derivative test is like that? In other words, why? So what is the second derivative test? Does someone have in mind actually?
So in second derivative
So you need to find the critical points first.
Yes.
Okay. So in other words, you need to find derivative test is that you need to find critical points first. Okay. And so imagine that you have these A, B, C as critical point, or A is some critical point. In other words, that you have this point where f prime of A is 0. Okay, it's a critical point. And then you say that just check the sign, just compute the second derivative and check that whether you have, what do you call, if this guy is negative, then you say x equal to A is maximum actually, interestingly. Okay? And if really the f double prime of A is positive, you say that x is equal to A is minimum. Does that make sense? Okay? Question: why you have the way it is? So you often hear an explanation. If you look at the second derivative of it, it just tells you that whether the curve is, concave up or concave down actually. So if it is concave down, it's going to be a maximum. Okay. So in other words, this is telling you that at A the function is concave down actually. So it's like concave down, and here it's concave up. Okay. Therefore, this must be maximum. This must be minimum. But the question is, just near, you feel nahi hota, you just need to believe it. Okay? But you can really see it. Think about it. So what does f prime is telling you? So f prime is telling you that how f is changing actually. Okay? And f prime of x. One interpretation of f prime of x is that, okay, how the f is changing. And when you say, what do you mean by f is changing? What you actually mean that how the tangent line on the f is changing actually. Okay? How the tangent line on f is changing actually. How, okay, how the tangent line is changing over it. Okay, so you just want to, in other words, you are asking what is the slope of the tangent line at the point x actually on the curve, whether it's positive or negative. So this guy is representing slope. So that's slope. Slope of the tangent line. Now think about the second derivative. So what does this mean?
सर वो जो स्लोप था वो बता रहा है कि वो इंक्रीज हो रही है, जो बताएगा फंक्शन के बारे में कि वो इंक्रीज हो रहा है डिक्रीज हो रहा है। सेकंड टेस्ट फिर बताएगा कि इंक्रीज हो रहा है तो किस तरीके से इंक्रीज हो रहा है, कॉनकेव अप के तौर पे या कॉनकेव डाउन। तो ये सेकंड
वही बात हो गई। So in other words, this is telling you, so when you don't have this, so this is really the slope of the tangent line.
So ये शायद ये बता रहा है कि फंक्शन इंक्रीज हो रहा है इंक्रीजिंग रेट पे, या इंक्रीज हो रहा है डिक्रीजिंग रेट पे, कुछ इस तरीके।
समझ आया ना? So what does this is telling you? So you have a slope, and how does this slope is changing? So previously you had an eye on the slope, but now you want to look at how the slope is changing. Slope itself is changing. Now think about it. If f double prime of a is negative, what does it mean? So this slope is happening what?
कॉनकेव डाउन।
What is happening with the slope? It's decreasing actually. When you are having, for example, f double prime of a, what you're actually saying is that the slope is decreasing. Okay? And when f double prime of a is positive, what does this mean? That the slope of the tangent line is increasing gradually as you move near to the critical point. And here's the thing. And you see this, that whether this happens or not. Think about it. So what is the slope of the line here?
पॉजिटिव।
Positive. How about it now?
पॉजिटिव।
It's positive but less.
डिक्रीज हो रहा है।
The slope is decreasing actually. The slope of the tangent line is decreasing. Okay? And what is happening? It's even more decreasing. Even more decreasing and eventually becomes zero. And then what happens? It goes crazy, it becomes negative. And becomes more negative and more negative and more negative. In other words, that what is happening before and after this point is that function, the tangent on this curve is losing more and more and more slope actually. So that's essentially it tells you. That's essentially it tells you. Now think about it. So instead of taking x square, let's think about it to be the positive square. So what is happening with the slope now? Okay?
स्लोप नेगेटिव है लेकिन डिक्रीज होता जा रहा है वैल्यू।
So the value of the slope is increasing.
अच्छा।
Increase हो रही है। पहले increase कहा था, decrease कहा था, क्या कहा था?
स्लोप नेगेटिव है।
Increase कहा था. So now what is? So it's negative, but less negative.
लेस नेगेटिव।
And less negative. Okay. In other words, that if it is less and becoming less and less and less negative, that means that it's gaining the value.
Gaining the positivity.
Okay? You know, the change in the slope. You are computing the change in the slope roughly. Okay? You are looking at how the slope is changing. And it turns out that the slope is getting gradually more and more and more and more positive. So the point around which the slope is getting more and more and more positive, that must be minimum. Slope of the tangent line. Whenever I'm saying slope, I mean the slope of the tangent line. Take it? Just read the natural idea. Okay. And I tell you next. You define what should be the definition of the maxima of the extreme points in, for example, two dimension actually, for a scale of physics. if I give you an opportunity, keep this intuition in hand. Give me a definition. And what do you call? By the way, there is also an interesting situation. That is what you call inflection points. What are inflection points?
concavity change उस पॉइंट के पहले
Concavity is changing.
एक साइड पे डाउन है तो अप हो, अगर अप है तो डाउन.
So let's see a concavity point and let's see what happens. So one thing is for sure, here the slope is increasing, but increasing in a
decreasing.
So it's a slope
decreasing in increasing rate sir. ये
decreasing and increasing.
Yes, decrease हो रहा है slope sir. और value
increase हो रहा है भैया.
सही हेट है जो.
Slope is becoming more and more multiplied. The function is decreasing. Okay, the function is decreasing. The slope of the tangent lines on it is increasing. Okay, is it making sense? So it's always increasing. It's not a point where it decreases. And how about other way around? ठीक है, जब minus x square था, remember? So what is happening is that you are losing the slope.
Function increase, slope decrease.
So first you have a very positive slope, very high slope. Okay, in other words, that you are going really fast, huh? And you lead here, and then you got, you kind of become slow. But what does this practically mean is that your slope is going down, as you move along the curvature. Yeah. Should make all sense. That's what the secondary is. So this is not easy. Okay, so usually people memorize it in the terms of concavity and so on. So another slope is unanimous actually. It has one specific kind of a behavior actually. In it. Decreases around that point. Around that point. Okay. Before that point you can go crazy, can sometimes increase, sometimes decrease, but around that potential maximum or minimum point is going to have a unique behavior. Either it's only decreasing or only increasing actually. Okay? Now, what would be the more crazier point? The more crazier point is going to be when you're going to look at, for example, the cube. Okay? Look at the cube. So, what is happening with the cube actually? So, what is happening with the slope?
Slope decrease. Increase हो रहा है. Increase हो रहा है.
Increase हो रहा है.
Decrease हो रहा है.
You have a more and more slopy line, and then it gets less and less slopy. Okay. And it gets eventually zero. And then increasing again actually. So in other words, you don't have a unanimity of the slope actually. So before that point the slope was going down, and after that point the slope was going up. It's changing its behavior.
But here not changing.
Okay. While in case of the maximum and minimum, it's not changing the behavior. So if it is decreasing, it's always increasing before and after.
तो या मैक्सिमम नहीं होगी.
Slope, not the function of it.
तो सर ये मैक्सिमम पॉइंट नहीं होगी फिर.
So you're gonna call it as inflection point.
ये कब पॉइंट है?
ठीक है, is it making sense?
Yes.
So concavity.